Okay, so today is December 2nd, 2011. We're on 6.5, the lesson. I'm going to give you a brief look at 6.4. We're going to just explore a pattern in exponents here for a minute. So I want you guys to make a chart. Recording again. So you have a chart like this. It's a chart about exponents, and we're just going to quickly investigate looking at whole numbers as exponents, negative numbers, and fractions as exponents, and how they would change in terms of our evaluation. So what I'm going to do is I'm going to start with my base number. My base number is going to be 1. Okay? So for the very first row, the base number will be the number 1. And I'm going to have the number 1 to the exponent of 1. Or actually, you know what? Let's square it, just so we can see some kind of difference. So we have 1 to the power of 2. We have 1 to the power of negative 2. And we have 1 to the power of a half. Can you guys see that? Let's fix that half. The power of a half. 1 to the power of 2. Anyone know what that is when we evaluate it? 1 times 1 is 1. 1 to the power of negative 2. Do you guys remember our little rule, what we have to do when it's negative? Anyone know? Nathan. Yeah, we're going to flip the base to make it positive. So we have power of negative 2. We would flip this to be 1 over 1 to the power of positive 2. And in the end, we get 1 over 1, which is going to equal 1. So our answer ended up being the same. And finally, 1 to the power of a half. Okay? I'm going to show you that calculation. And this is where we're talking about our radical exponent here. Okay? So, if you guys look, we have our numerator, which is a, and our denominator b. And this is how it's going to affect it. In our case over here, we have a numerator of 1 and a denominator of 2. So we have 1 to the power of 1 over 2. Our denominator is the number 1. So essentially what happens is I keep the same base, and it's now put to the power of 1. That's our green one. You know what? I'll put these in colors. Okay, so this will be green. What 1 to the power of a half is. The 2 becomes a square root, or in this case, the root of 2. So this symbol, base 1 to the power of a half, we take the number on top, our numerator, and we put the base to that power, but we also root the number, so the root of 2. So we're looking for essentially the square root of this number. So what is 1 squared? 1 to the power of 1 is 1. So we're still left with the square root of 1. We evaluated 1 to the power of 1. What's the square root of 1? 1. In this case, our whole number, our negative, and a fraction all gave us the same answer. But this is going to change. Our numbers are going to be very different here. Okay? So, in our next question, we're going to have 2 to the power of 2. We're going to have 2 to the power of negative 2. And we're going to have, I'm going to change this number to 4 to the power of a half. Okay? And you're going to see the reasoning before this. So 2 to the power of 2. What is 2 times itself? 4. We got that. What about 2 to the power of negative 2? So when we have 2 to the power of negative 2, we'll do a little side calculation down here again. 2 to the negative 2, to make it positive, it becomes 1 over 2 squared, which is 1 over 4. So in this case, our answer is 1 over 4. And in our other one, 4 to the half. Okay? Remember, we're taking 4. My numerator is 1. My denominator is 2. So I represent this as the radical of 2 and 4 to the power of 1. What is 4 to the power of 1? 4. So we're looking for the square root of 4. What's the square root of 4? 2. So our answer in this case is 2. Okay? We're going to do one more. This time I'm not going to use any side calculations. I want you guys to try to catch this pattern. 3 squared, 3 to the power of negative 2, and the 9 to the power of a half. What is 3 squared? 9. 3 times 3 is 9. 3 to the power of negative 2? What was that? 1 over 9. So if you notice, we took our 4, and for our negative answer, it was 1 over that. Yeah. We would have 1 over 9 as our answer. And then in this one, when it's the power of a half, essentially it's asking what's the square root of 9? It's 3. So our answer is 3. So lesson 6.4 was just going through all the different types of examples like this. We're going to go through actual questions, okay? They wanted you to test out from 1 to like 50 doing this pattern all the way through. We're going to go and do a couple questions like this, okay? Okay, our very first example is 49 to the power of 1/2. So first of all, we're going to go through our rules, and I'm going to quickly look. We're talking about a radical exponent in this case, okay? So because we're dealing with a radical exponent, I want you guys to take a look at this. Our a value is the number 1 in this case. So our a is equal to 1. Our b value is the number 2 in this case. So our b is equal to 2. So what we're going to be doing is we're going to be rearranging this version of it like this. X is our base. Our base is the number 49. Okay? So when we go to rearrange 49 to the power of 1/2, we're going to get 49. Our a value was 1, so 49 to the power of 1. And this tells us which root it is. Our b value is 2, so we're to the second root. So in other words, when we're to the second root, we're looking for a number you multiply by itself twice to get what is underneath this bracket or this division looking sign. Essentially, it's called a root. So what is 49 to the power of 1? 49. So we have the second root of 49. What number times itself is equal to 49? Bronson? 7, that's right. So our very first one, essentially, when they asked us for 49 to the exponent of a half, they were looking for the square root of 49, which is the number 7. Okay? Let's try the second example. Okay, the next one they have here is negative 64 to the power of a third. Okay, so this one's a little more difficult. Our a value here is what? Is 1. And our b value is the number 3. We're putting a and b because that's what we have as our... The one on top is the a. Just like we have here, top of the fraction, bottom of the fraction is b. Yeah, we're talking about fractions right now as exponents. So when I go to rearrange this, we're going to have negative 64 to the power of 1. That's our a value. This time we're looking for the third root. So a number multiplied by itself 3 times, that's going to equal whatever's underneath here. So I'm going to evaluate what's underneath. What is negative 64 to the power of 1? Negative 64. So then we're looking for the third root of negative 64. So I need a number multiplied by itself 3 times, that equals negative 64. That would be a square root, but we're looking for a third root. So not a division. We're looking for a number that it would be the number times itself is going to give us negative 64. What is it? Negative 4. So if we take negative 4 times negative 4 times negative 4, let's take a look. What is negative 4? We'll do it just in pairings to start. What's negative 4 times negative 4? Positive 16. So I have positive 16 times negative 4. All right, let's do this on the calculator. 16 times negative 4. Can you guys see that? Negative 64. So the third root, let's put our answer down here. We'll consider that was a little side calculation, okay? So we'll put something around that. That was our side calculation. Our third root of negative 64 is negative 4. So if we were to evaluate this, the answer to negative 64 to the power of 1/3 is negative 4. Okay? We're going to go through quite a few of these examples. Example 1C. Like usual, we're working with a radical exponent, like we said. Our radical exponent, we're going to just clarify what our A and B value is here. So our A in this case is what? 4. Our A is equal to 4. Our B is 5. So B is equal to 5. And we go to rearrange this, okay? Now, I'm going to show you 2 different ways of going about solving this question. So we're going to split this in half here. Now, we can rearrange this, first of all, to be 32 to the power of what? 4, right? That's our A value. And what root are we looking for? The 5th root. Or this could be arranged to look like this. Still the exact same, but we'll do it in a different order. We'll still have 32. But this time what we'll do is I'll do the 5th root first. And then I'll put it to the power of 4. So, these 2 versions are equivalent. I can either deal with the power in the radical first, or I can deal with the radical itself and then the power. So either the power, then the radical, or the radical, then the power. Both will get us the same answer. One will be a little easier to do mentally than the other. No, you don't technically have to. Good to know. Okay, so I'm going to do the one on the right first, where we have the 5th root of 32. Does anyone know what number multiplied by itself 5 times would equal 32? You guys just guessing? Try it in a calculator. Try writing it out. All right. The 5th root of 32. We're going to give that a try. Okay? Actually, let's undo that second line. So let's try 2 by 2 by 2 by 2 by 2. Okay? So if we do a pair at a time, 2 times 2 is 4, and I still have to multiply 4 by the number 2 3 times. Then we'll do the next pairing. So let's try 2 by 4. That gives us 8. We still bring down our other 2. So 8 by 2 by 2 again. We'll do the next pairing. 8 by 2 is 16. Bring down the other 2. 16 by 2 is 32. So the fifth root of 32 is actually the number 2. Oops. Scroll down here. So now that we have that, and what's really good about having done this is now that we've figured out the fifth root of 32, was the number 2. Inside the brackets, we're left with the number 2 to the power of 4. What is 2 to the power of 4? 16, that's right. We've calculated. It would have been the step before the 32. So without using a calculator, I was able to calculate that 32 to the power of 4 over 5 is 16. Now, on the left side. No, don't do that difficult. The next question is a little more difficult. We're going to deal with the exponent first. So I have 32 to the power of 4. So when I type this in, we get 32 to the power of 4. I actually can't see that far. What is that? 1,076? Perfect. Thank you, Bronson. So, that one clearly we needed a calculator to calculate. That would have took us a very long time. Next, I could put the fifth root. Now, for many of you, this is going to be new to you, putting a fifth root in a calculator. Okay? So when you go to put a fifth root in a calculator, you're going to be looking for a symbol that has an x before a square root sign. So here I have my square root sign, but I need an x before it. So I'm going to look, sometimes it's the shift of that button. So again, we're looking for the x in front of the square root sign. When I hit shift, it comes up here. We have x, the root of x to y. So I'm going to push this button, and I'm looking for the fifth root of that number. Which is 1,048,576. The fifth root is 16. So it didn't matter which order we did it in. We got the same answer. One of them we could, well, most of us would be able to do mentally when you look at it. The other one we would have needed a calculator, otherwise it would have took us a very long time to solve this question. What was important is that you can do this either way and you'll still get the same. Okay, the very last example we're going to do today, this is the first half of the lesson, is we're going to be finding 0.04 to the power of 3 over 2. Now, again, finally, we're working with a radical exponent. So we need to just define our a and b values in this case. Our a value is 3. Our b value is 2. Now we're going to do this one same way we did the last one. I'm going to split it into 2 versions, whichever you feel more comfortable with, you can use. So, our first version, I'm going to drop the colors this time. I want you guys to get used to writing with just your pen or pencil now. We know our x value is going to be 0.04. In the first version, I'm going to deal with the exponent, which is our a value 3. I'll solve that first. Then I'll look for the second root, or we know it as a square root. Okay? In the other example, we're going to deal with the square root first. So we have 0.04. I'm going to look for the square root first, and then I'm going to put it to the exponent 3. Again, we'll still get the same answer. I just want to show you both ways to do this. So I'll do the one on the right again. Square root, I'm looking for a number times itself that equals 0.04. Might be hard off the top of your head, so we're going to type it into our calculator here. 0.04. This is my square root sign. 0.2. Worked out nicely. Okay. So I want you guys to actually think about that. 0.2, when we squared it, it became a smaller number. Okay? That's very important. This is a larger number than this. Normally when we square root, we're working with larger numbers, something like 9. Square root of 9 is 3. We usually get a smaller number as an answer. When you have a decimal and you square root a decimal, or you find the root of any decimal, you'll actually end up with a larger number as your answer. I want you guys to just take note of that relationship. Decimal, the root of a decimal is a larger number. Okay? Now, finally, 0.2 to the third root. Now, in the third root, again, I got to figure out how to put it in my calculator. I might not have that option. So you're going to look for the exponent of x. So I have y to the power of x here. I click that, and it's to the third. So I'm looking for the power of 3, 0.2 to the power of 3. I get 0.008 as my answer. Okay? Our other example, we said we were going to do the exponent first. So we're going to be looking for the second root, 0.04 to the third root, to the power of 3. Gives us a very large, not large, but a very small number, a lot of decimal places. How many zeros are in front of 64? 4. So we have 1, 2, 3, 4, 6, 4. That was 0.04 to the power of 3. And then when we square root that number, luckily I have that button right here. I've kept the number in my calculator. When I square root it, I get 0.08. So I took two different roots to get here. Both of them gave me the same right answer. Okay?